Thank you very much, Frank. So I'd like now to present a rather deep dive into 5G URLLC. Maybe it's more kind of snorkeling due to the limited time. So if you go on the next page, this is an example of different kind of applications in 5G, which are related to 5G ultra reliable low latency communication. And you see it is a really big mixture between machine setup via augmented reality, monitoring of process parameters, transfer of sensor data and systems, also to support field buses or Ethernet IP, Modbus, EtherCAT, Profinet, TSN, IRT. And so that's a really big mixture, which is not supported by the initial release of 5G, the release 15, which was concentrating, as Karin also mentioned, on mobile broadband, enhanced mobile broadband. Certain applications relevant for URLLC and industrial applications are already supported, like Modbus or Ethernet TCP/IP, but not all of them yet. And this is due to the nature of 5G. There are the releases, and in every release there are extensions planned to support the different vertical industries as well as the 5G system as is. And these are all use cases from the VDMR Leitfaden. There's a web page available. I think I also have a link later on in the references, where you can have a detailed look in the individual applications. Okay, now let's have a look on how all these different applications are implemented. Of course, not a single application will be present in a production site or somewhere else in a campus network. So it's normally always a mixture of different kind of these applications, which means proper quality of service management is definitely required, which is luckily also embedded in 5G. There's a specification available, the 23501, which defines the QoS management. And there are different kind of QoS flows defined, of course, both for uplink and for downlink directions. One is the guaranteed bitrate kind of QoS flow, like voice applications, that's already present in LTE, but now it's also usable for process automation purposes or for video, for surveillance, also for remote driving, where video camera data are sent to a remote driving center. Then there are the traditional non-guaranteed bitrate traffic, which is more or less internet traffic without certain requirements for latency or throughput. And new in 5G, that's the delay critical guaranteed bitrate for machine controls, where latency, as mentioned by Frank, plays a role. And I think it is worthwhile to mention that you do not necessarily need slicing concept, which is kind of a virtual embedded network inside your 5G network to support all these kind of QoS, but it is possible to embed multiple QoS flows in parallel within a single slice. So that's shown on the figure. We have an user equipment and user plane function UPF on the network side, and the access network, the radio access network with the base stations. And then we have a mapping of application and service layer data and streams to specific QoS flows, which are then handled by the base station as well as by the UE. And that's the essential. The QoS flows are supported completely in the network, in the core, as well as in the radio access network and in the user equipment. So that's a very important feature to support multiple applications at a time. And now if we have a look on the next slide, In the specification of 5G, we have the QoS profiles, including parameters like resource type, as mentioned on the last slide, the priority level, if we have multiple delay critical guaranteed bit rates at a time. That's important. We have a packet delay budget or an maximum delay which is allowed. The packet error rate, of course, plays a role for the availability and other parameters like averaging window or guaranteed flow bitrate. Here down on the left side, we see the delay critical guaranteed bitrate down to 10 milliseconds or 5 milliseconds of delay, end-to-end delay, and the availability like 10 to the power of -5 packet error rate. So these are values which are currently standardized. You see also it is not going down to 1 millisecond, which is oftenly mentioned in the in publications about 5G. So that's the current situation, down to the power of 10 to the power of -6 in block error rates, or down to 5 milliseconds end-to-end delay, which is standardized. Of course, if you have a local network, you can reach lower values, but this is not specified in 5G. However, should be available also in real implementations, which we also like to test in our 5G Bavaria testbed, either the campus network or the Industry 4.0 testbed. Okay, so on the next slide. Yeah, thank you, Frank. That is an additional protocol which was embedded in 5G to support these kind of simultaneous QoS classes and QoS flows. So it's called Service Data Adaptation Protocol, and it is on top of the traditional protocols already defined for LTE from physical layer, MAC layer, RLC, and PDCP. And now we have the SDAP sublayer, which is mapping the different QoS flows to the specific data radio bearers for the transmissions. That's done via an QoS flow ID. And of course, that's a parameter which is propagated through the complete 5G network, like radio access and 5G core network, down to the UE and back. Okay, thank you. And other parameters for the reliability, that's the so-called packet duplication, mentioned by Frank as well, to repeat a transmission. So here it is called packet duplication, to transmit data packets twice, either in a carrier aggregation scenario, then it's done on the MAC layer, when you have multiple component carriers which are transmitted at different frequencies. You can transmit data packets twice. Or if you have dual connectivity, your user equipment is connected to 2 base stations at a time. And then also duplication of packets is possible. But packet duplication is not possible within a single 5G carrier. So that's not supported. Well, other methods to improve reliability for 5G URLLC are channel state information feedback by the user equipment towards the base station for a more accurate usage of modulation encoding scheme. So these are different parameters here for reliability and for the latency. You see in the picture here, we always have 10 milliseconds radio frames, which are split into subframes and then split in OFDM symbols. And in LTE, the transmission time interval was had been slots of 500 microseconds. That's the smallest granularity. It was slightly improved in the LTE shortened transmission time interval, where it was split to, let's say, 3 instead of 7 OFDM symbols, decreasing the time below the 500 microseconds. But with the new numerologies of OFDM in 5G, we have now shorter slot times down to 125 microseconds, and even so-called mini slots So the granularity is much smaller to support low latency communication in 5G. Okay, and then another method which is quite useful for, especially for industrial applications, are the periodic for periodic traffic is grant-free uplink transmissions to avoid that user equipment has to request resources for an uplink transmission. The same is possible also for downlink, called semi-persistent scheduling. So periodic traffic can be once configured, and then let's say it's quite easy to make periodic transmissions without any resource request. And another method for improving for time-sensitive networks, that's the enhancements even to compensate for propagation delay. And that's quite important to support the very strict, to support strict requirements for time-sensitive networks. So you see there are lots of methods embedded in 5G to support 5G ultra reliable as well as low latency communication. And if you're interested, I summarized here a few publications from use case overview in technical report. We have some use cases and requirements from the 5G Alliance for Connected Industries and Automation. We also have the detailed VDMR Leitfaden. I forgot to mention the use cases, which are also publicly available, and also some specification for the one who is interested in more details. And well, all this QoS is defined, but how good it will behave in reality is, of course, quite interesting and challenging. And so we also have, through 5G Bavaria, the program for test center and testbed, also possibilities to test with you also QoS and reality for your applications. So many thanks for your interest, and would be happy also now to answer your questions.